How can we combine mass-scale AI-assisted analysis of television and online news to combat misinformation and help us contextualize the narratives around the world? It has been just about 60 years since the first commercial keyword search interfaces like Dialog. Today, we think of access to information increasingly through the lens of keyword search. Even university research libraries are increasingly moving their stacks to offline storage facilities, meaning the serendipity of walking through the stacks and discovering information that you didn't expect is coming to a close. And that ability to sort of navigate and visually explore is also largely coming to a close. Essentially, information today is accessed through keywords. For television news that's closed captioned, we already have something called the Television Explorer in collaboration with the Internet Archive's Television News Archive that extends the concept of keyword search to the spoken word transcripts of television. In other words, you can type in a keyword here and get back these timelines. How often is it being mentioned? What times of day is it being mentioned? Compare it across channels, do all kinds of very interesting analyses. But of course, that's the spoken word. And a lot of text on television news is actually on screen. So using AI, we're now performing OCR on a selection of channels that allows you to extract out the on-screen text, whether it's in about almost 300 languages now, including here, we can actually see Urdu language material actually on an ABC evening news broadcast unexpectedly. And of course, worst case scenario OCR here. And so transcribing that. So in other words, today you can keyword search the spoken word, but also the on-screen text. But as we look around the world, it turns out that American television news is an anomaly with its high quality human transcribed closed captioning and copious on-screen text. In much of the world, we have no closed captioning, and on-screen text like chyrons is almost non-existent. So while machines can perform feats of wonder in textual analysis, even the most powerful tools today for visual assessment are still quite limited. The most advanced state-of-the-art commercial neural video analysis tools typically recognize about 10 to 20,000 objects. So they could identify maps and bookcases and masks and even golden retrievers. But beyond those 20,000 or so categories that most systems support, the vast visual landscape of television news remains largely inaccessible. In fact, so many of the questions that interest scholars, really, if you think about it, revolve around the visual portrayal and visual narratives of mediums like imagery and video. So in 2020, as COVID-19 swept the world, how often were masks portrayed on screen? But more importantly, was the pandemic told through the eyes of studio presenters, field reporters, medical professionals, political reporters or political leaders, scientific leaders, pundits, citizens on the street? Did leaders, through their body language, project calm? Or was it panic, concern, or dismissal? Was it a president at a podium, a doctor in a hospital, or a pundit in their home? Were public service announcements aired throughout the day, reinforcing public health messaging? Machines can help with bits and pieces of this, but no commercial tool today can really address these questions directly. This is where the human brain really shines above AI. But this means that a real live human being would have to watch millions and millions of hours of television news linearly to try to understand and catalog this. There's really not a way to skim television news at scale. In the case of today's inflation, we have the same issue. I can keyword search the word inflation or how often it appears in the on-screen text, but what's the imagery used to convey it? Is it gas pumps for transportation, power lines for energy, empty store shelves for food, price tags, politicians, infographics, panels? Machines can do bits and pieces. They can recognize certain things and catalog certain things, but it's difficult to have machines really kind of help us assess and truly understand what are the dominant visual narratives right now, whether it's a pandemic or inflation. Now, the Russian invasion of Ukraine drew all these issues to the forefront. There's an urgent and critical need now to understand the domestic narratives and framing of the war. Machine transcription of Russian is quite good, but machines transcribe literally. So a native speaker might hear Third World War, whereas the actual word might be the third of a truly world involving wars. And this can make keyword searching a little bit difficult, especially when we look across languages, especially when you involve translation and all the other factors that are there. But most importantly, there's some Chiron text in Russian television, certainly, but it's not dominant. You don't have the 24/7 editorialization and summarization of US television news. But if you look at the imagery we have here, so much of this, the real narrative of the war, is communicated through visual narration, not through the spoken word. Certainly the spoken word is important, but it's really the visual imagery. How much are they showing war footage? How much of it is leadership? How much of it is sort of scenes with normalcy? In fact, if you think about it, a central tenet of modern media scholarship of war is really how the story of war is being told through imagery. Machines can tell us that this imagery has tanks in it. It can tell us that there's gunfire here or podiums there. It can tell us what flags are on screen. It can tell us a lot of sort of the basics. But it can't tell us the far more important questions of framing. Questions like, is one side being portrayed as winning and the other losing? Are maps that once showed the entire country now zooming in to avoid showing areas where one side is losing ground? Are camera angles changing to mask health issues from a leader? Is a leader projecting calm and confidence of victory or showing concern and worry? Is combat imagery rah, rah, onward to victory? Or is it switching to grittier imagery of the reality of war, potentially suggesting that the state is preparing its citizenry for reduction of operations? These are the kinds of incredibly complex and often very subjective questions that scholars pose of war imagery that still really require humans rather than machines. So how do we take this 24 hours a day of broadcasting on a given television channel and make it rapidly skimmable? Fast forwarding television clips still means you're accessing a broadcast through a narrow window that's moving through the entire day, like a flashlight in a vast darkened warehouse. But what if we represented television news broadcasts as clickable sequences of thumbnail images? So what if we sample the broadcast every X seconds and turn to a grid of thumbnails, arrayed vertically, where you can go through and see an entire broadcast, and then click on a given thing and say, wow, here's Tucker Carlson on Russian state television, and then instantly see what are the clips that they're showing of his shows. Who are the major politicians that Russia is airing to talk about? Who are sort of the major figures, whether it's Biden that they're airing to criticize a statement, or perhaps a Fox News clip that they're airing to laud and support their goals. And this is very similar to those that are familiar with video editing, a very similar concept, but arrayed vertically rather than horizontally, and allowing you to rapidly scroll through broadcasts. But how do we create those thumbnails? And there was a huge amount of research that went into all the different ways that you could transcribe a broadcast into a sequence of thumbnails. And in the end, what we discovered, whether it was Ukraine or COVID or inflation or any of the other topics, and from television channels all across the world, was that one frame every 4 seconds. So take a broadcast, and every 4 seconds, take a frame. That pretty much does the best job making it rapidly skimmable and compact, but also covering most of reality. So what does this actually look like in real life? So this is an example of the Visual Explorer on a given broadcast. So this is One TV, a Russian television channel. So here we can see they're airing studio. We can see here they have the president of Ukraine. Now we can see presenters with the Russian Z on their shirt. Now we can see combat imagery. And so really, immediately, without knowing anything else, without speaking a word of Russian, I can see this broadcast is sort of studio. They're showing some clip from the Ukrainian president, sort of a commentator giving an update, and then footage from the field, so to speak. And this is all interactive. You scroll through this and click through it. And if you click on any thumbnail, instantly up comes a broadcast. You can play a 30-second clip of it right there. You can also, most importantly for misinformation researchers, you can download a zip file of the full resolution thumbnails of that broadcast so you can deduct your own analyses on that. So essentially, it's a new interactive interface to the Internet Archive's collection, presenting it in a powerful new way. Originally, this launched with Ukraine, Belarusian, and Russian television. It now spans 24 channels from 7 countries and 4 languages, covering the majority of the active channels in the Internet Archive's television news archive. So that's the Visual Explorer. Now, where are we heading with this? Well, there's a lot of different things that we're exploring in the misinformation space. About a year or so ago, we collaborated with First Draft. And what we did there is we actually used that on-screen OCR, where we're extracting out the on-screen text, to identify every one of Donald Trump's tweets that was appearing on a set of major television news channels. And then we actually went back to the Trump Twitter archive so we could actually catalog every one of his tweets and how often it appeared on television news. We were showing that we were actually able to show that when Twitter flagged these, that was actually backfiring by drawing far more attention to these tweets and driving them back into the media cycle. We're able to do other interesting things. So remember, we have that on-screen text. So we can look at the Chiron text here. We're able to actually generate a day-by-day chronology of all the medical doctors that were being interviewed on television news. So in other words, when, say, Fox News is talking about COVID, who are the doctors that they're interviewing on screen to tell that story? Same thing on CNN and MSNBC. And we can see specifically what their affiliations are and what their specialties are. So you can see kind of infectious disease, sort of a start of any doctor that would answer the call to infectious disease, the vaccinologist. And you can also see kind of the fringe doctors that are used more on, say, Fox News, for example. But we can do some really interesting things here. So by using the closed captioning is text. So we can compute embeddings on those, so document level embeddings. So here's a case where we took a fact check from factcheck.org, and we just took this paragraph of text and pasted it in. So this is the false claims that the COVID vaccines have microchips that will let people be tracked. So we just took this, computed and had it compute embedding on it. And then we scanned closed captioning over a series of days and said, find the statements across television news that's most similar to this. So here we can see a couple of statements across Fox News, BBC, MSNBC, CNN. We can see statements that are closely aligned with that. Now, again, some of these we can actually see, on Fox News here, they're actually giving some, they're actually sort of promoting this falsehood. Whereas here you can see in the other channels, they're just sort of saying, look, there is this falsehood out here. What's fascinating about this, again, is this ability to just say, so in other words, we're not fact checking this. We're saying, let's scan television news for references to things that have already been fact checked. And you can see what's fascinating here is nanochip is able to, again, the embedding is able to see a nanochip's basically the same as a vaccine here. Now, here's a more interesting case. So remember, that was on text. What about the visual dimension? So here's a clip that aired on CNN. It's just a clip of someone, and it was just somewhere in Russia. No information on what this is. So what we did is we took this broadcast, we took still frames for this broadcast, and we ran a reverse image search. So Google has something called Google Cloud Vision, which is basically visual assessment of imagery. And it has something called web entities, where it can do a reverse image search across the open web and find you other occurrences of this across the open web, the URLs of those, and how it's typically captioned. So we started with this, and then we immediately then found that this was actually, we were able to find the original source imagery of this. As a nurse, we were able to find it was sourced from Moscow 24 and an actual text. And then as we continued to search across the web, we actually got the entire description of it. So we started from sort of this image that appeared on CNN, where there's no context. Where did this come from? What is this depicting? And then again, completely automatic, no human in the loop. We go to this complete paragraph length description of it. Now, again, this was a one-off deal, but we actually can apply this to an entire broadcast. So this was a CNN broadcast of COVID, and we had it do every second, do a screen capture of that, and repeat the same process. So every 1 second, extract a screen capture of that, search the open web for other instances of that imagery, and then we would take each of those occurrences on the open web, scan them for EXIF metadata, and then enrich it with descriptions there. So here we can see this image here. We actually showed this was actually stock imagery from Getty Images. We're able to show here, this was actually a wire image here, and we can see the complete description of what this is depicting. So again, that ability to lend context to television news. And we're also looking at other ways. So for example, we can take video and run it through, for example, Google has something called Cloud Video. There's visual assessment. So we can extract out the text, we can recognize the logos, we can see how many people are depicted on the screen. Again, no facial recognition. We can see how many people are on there. Are they looking at each other? We can do all kinds of analysis there. We actually took an entire episode of Anti-Fake, which is a fascinating show. So Russia realizes that unlike China, it can't really control the flows of information as well as China can. So instead, whether it's Bucha or any of these other stories, it's flooding the airways with information, just saying, look, here's all the stories you're going to see. It's all fake. So again, that weaponization of the concept of misinformation. So here we took an entire broadcast and ran it through and actually released all the annotations so you can see what it looks like. We're also looking at automated transcriptions and translations. So basically taking a broadcast and generating Russian and Ukrainian language transcripts of them, 13,000 transcripts to date, and then what it looks like through machine translation there. And then the future. So obviously this is all about what I've just shown you is television news, but what about multimodal context? So GDELT has historically been best known for its deep real-time monitoring of local news across the world, which today spans more than 150 languages. GDELT was used to detect some of the earliest glimmers of Ebola and actually was used to send one of the earliest worldwide alerts of COVID-19, actually detecting an anomaly, a strong anomaly of a SARS-like viral pneumonia of unknown origin at 10 p.m. Eastern Time, December 30th, 2019. And this fall, we'll actually be relaunching GDELT Live, which is our real-time visual dashboard of breaking and major news stories from across the world, allowing you to, in real time, sort of see what are the major stories breaking across the world, and specifically contested narratives. And this is where things get really interesting, is this ability to look at what are the stories that are breaking where there seems to be a lot of disagreement in the facts. So we have this vast graph of entities mentioned in the news. We can start looking at the context and what are some of the connections maybe that differ between different portrayals of a given story. And we can also look at the dependency graph. So we can ask questions of this, actually literally Q&A. Did Donald Trump meet Al Gore? And the answer is yes. We can answer that completely autonomously. But then more interesting things. So again, coming back to contested narratives. So did climate change contribute to Australian wildfires? So this is the question you start with. And then scanning, using again those dependency graphs, we can see just within BBC News, one single news outlet, we actually get yes, no, and maybe. So 3 different answers, again, starting with these questions. So again, looking at contested narratives there. And then more broadly, using those embeddings, those document embeddings, combined across online and television news, we can start clustering stories. So completely multilingual, we can say this is actually, so this particular graph was created of a question of what are the COVID-19 vaccine narratives that are out there right now? So we know the major narratives that are out there, but what are all the narratives that we don't know right now? Sort of the emergent narratives, the emergent false, some are true, but a lot of falsehoods that are spreading. So we can start seeing things like this and say, hey, what's going on there? So this is an emergent area, especially looking both at web and combining the two again, and combining those with fact checking and other sources of information. So again, to explore the Visual Explorer, just go to this URL or scan the QR code you see right here. And you can explore the Television Explorer and go to the GDELT blog, gdeltproject.org, to see all the different things that I've shown you. So thank you so much. I hope this has given you a very brief understanding of the Television Visual Explorer, some of the work that we're doing around contextualizing television news, and allowing us both to combat falsehoods, but to sort of empower fact checkers and others to understand those narratives there and to lend context. So to understand where's the story sitting there, whether that's sort of a you are here within the media landscape, or a you are here for this story in the broader media landscape there. Again, once public has sort of come up with their own entrenched views of a given narrative, it's going to be difficult to dislodge that, but you can certainly help people understand where do they situate within that narrative. We can help fact checkers understand how do we combat these narratives? What are the emergent narratives before they spread? All these different possibilities. So thank you so much for joining me here today.